Pluto made them come up and down. Pluto's circle crosses that of another planet. Pluto, the confounding little planet at the outside extents of our nearby planetary bunch, is stirring up intensity in the world of space science. Continuous reports demonstrate a possible encounter with Neptune, raising concerns among analysts and space fans. Notable figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the implications of this cosmic occasion. Yet, how did Pluto end up in an intense interaction with its bordering planet? Furthermore, what could this heavenly struggle mean for life on Earth? Join us as we unravel how something monstrous just collided with Neptune and how analysts have been left anxious by this gigantic abnormality. Pluto, once hailed as an irrefutable planet, went through a change in its status, being renamed as a dwarf planet due to its unusual orbit. No matter this minimization, Pluto still charms and interests the cosmic community. Recent assumptions from regarded specialists like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's trajectory potentially meeting with Neptune, showing an approaching series of encounters between the two great bodies, which could have critical repercussions for Earth. Pluto's journey around the Sun stands out because of its unique characteristics within our planetary system. Its orbit is surprisingly elongated, crossing a shocking distance since its discovery in 1930. Pluto still hasn't completed a full revolution around the Sun, adding to its persona. One notable aspect of its orbit is its extreme tilt. It drifts off by 17 degrees from the ecliptic plane, giving its path a more extreme grade compared to other planets. The combination of Pluto's inclination and its bent orbit presents layers of complexity to its orbital pattern. One exceptional aspect is its periodic assembly with Neptune's orbit. For about 20 years during each cycle, Pluto ventures closer to the Sun than Neptune, contradicting assumptions based on their different positions in the nearby planetary system. Delving further into Pluto's orbit, it's intriguing to note that it doesn't follow a perfect circle, but instead an elongated path resembling more of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its nearest approach, Pluto comes within about 30 astronomical units, AU, of the Sun, while at its farthest point, it reaches over 49 Australian dollars away, twice the distance of Neptune from the Sun. Additionally, Pluto's orbit is tilted at a significant angle compared to the orbits of the major planets in our solar system. This inclination not only adds to the complexity of its orbit but also plays a crucial role in its interactions with other celestial bodies, particularly Neptune. When Pluto approaches Neptune, their gravitational forces adjust their trajectories over time. The intricate dance between Pluto and Neptune highlights the dynamic nature of our nearby planetary system. While Pluto was once seen as a solitary wanderer in the outer reaches, its close encounters with Neptune emphasize the interconnectedness of celestial bodies, each exerting gravitational forces that shape the paths of others. In recent years, advancements in observational technology have allowed astronomers to track Pluto's movements with great precision. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely dismissed, prompting focused studies by the astronomical community. Despite its modest size and remote location, Pluto continues to command attention and interest among researchers and enthusiasts alike. The question emerges: why hasn't there been a collision between Pluto and Neptune? The answer lies in the gravitational pull from other planets. Cosmologists began examining Pluto's path soon after its discovery, and its orbit puzzled them. Unlike most planets that stay close to the same plane as they circle the Sun, the ecliptic plane, Pluto stands out with its steep inclination and oval-shaped orbit. The mystery deepened when they realized that Pluto's orbit crosses Neptune's. Despite these complexities, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Understanding how three celestial bodies move and interact gravitationally, such as Pluto, Neptune, and the Sun, presents a significant challenge. It's akin to attempting to predict where they will go based on where they start and how they pull on one another. For Pluto, this challenge reveals how its path, Neptune's path, and the Sun's path all work together, resembling a dance. Terms like precession, libration, and the VSOP variations help researchers solve this cosmic riddle. Simulation is crucial for maintaining planets in their orbits. When Pluto crosses Neptune's path, it is typically about 90 degrees away, preventing them from colliding. Libration ensures that when Pluto approaches Neptune or other large planets, it is well above their trajectory, reducing the likelihood of a collision. The VSOP oscillation, named after researchers von Zeipel, Poincaré, and others, explains why Pluto's orbit appears unique but remains consistent over time. Despite the chaos in space, certain patterns and rules keep things intact, ensuring Pluto's orbit remains stable and preventing collisions with Neptune or alterations in its path. The potential for orbital disruption illustrates how a celestial body's path is highly sensitive to its initial conditions. Indeed, even minor changes in its position or speed can upset its orbit over time. Researchers utilize virtual simulations to determine how Pluto moves in space. These simulations employ complex mathematics to model how Pluto interacts with other celestial objects like Neptune. By tweaking these simulations slightly, astronomers can observe how small changes can significantly alter Pluto's trajectory. In the late 1900s, these simulations uncovered something intriguing about Pluto's orbit. Despite various factors that should stabilize it, Pluto's orbit can still exhibit erratic behavior. Just a slight difference in where Pluto begins or how fast it is traveling can lead to substantial changes over many years. Nonetheless, even with this apparent chaos, Pluto's orbit remains stable for long periods, billions of years. This suggests that although Pluto seems tumultuous, its journey around the Sun follows a sort of pattern. Predicting what will happen with planets like Pluto, which have erratic orbits, is challenging. These systems are so unpredictable that it becomes difficult to understand what will occur in the long term. Simulations help us learn about potential outcomes, but they also show that we cannot anticipate everything entirely. Understanding Pluto's orbit is crucial, especially when considering the possibility of a collision with Neptune in the future. This knowledge enhances our understanding of how our nearby planetary system operates. Pluto's orbit teaches us that even orbits that seem unstable can maintain balance due to gravity and the movement of celestial objects in space. Continuing to observe and study these dynamics is essential for expanding our understanding of the universe and our place within it. When we explore space, we find that things can be strange, and Pluto's orbit is a perfect example of that complexity. Pluto's orbit is unlike those of other planets. It is more oval-shaped, which means it does not follow a perfect circular path. At times, it even comes closer to the Sun than Neptune does. This can create intriguing scenarios, as Neptune is also traversing its own path. While there is a slight chance that Pluto and Neptune could collide, they mostly manage to avoid each other due to something commonly referred to as gravitational forces. Gravity acts like an invisible force that pulls things toward one another. So, although Pluto and Neptune may appear to be on a collision course, their orbits are carefully arranged, governed by the pull of gravity. Pluto's orbit instructs us that space is full of surprises. What seems turbulent at first glance can be a delicate balance of forces. By studying Pluto's orbit, researchers gain insights into the intricate mechanics of our planetary system. This ongoing observation and analysis are vital for expanding our knowledge of the universe and our place within it. Imagine if Pluto and Neptune collided. It would be a cosmic event sending shock waves through our understanding of the nearby planetary group. While we have made progress in understanding space, the current situation indicates that we still have a long way to go. Focusing on how large planets affect Pluto's orbit provides us with valuable clues about how our entire nearby planetary system functions. It reveals that the position of each planet and their movements can change the paths of other celestial objects in space. Despite the complexity of space, some prominent figures worry that Pluto could collide with Neptune. This leads them to ponder why such an event could occur, even though it seems unlikely. Neil deGrasse Tyson, a renowned astrophysicist, has some intriguing thoughts about Pluto. He believes that renaming Pluto as a dwarf planet, rather than a major one like Earth, is a step forward. He thinks we are continually learning new things about how celestial bodies move in space. Tyson views Pluto's unusual orbit as a sign that there is still much we don't know. He believes that the mysteries of space are captivating, and significant events like Pluto's renaming pique public interest in astronomy. Tyson aims to help people grasp the cool and sometimes strange aspects of how space operates. He believes discussing the mechanics of space is essential, as they can astonish us. Tyson collaborates with other scientists to alert the public about the potential risks of Pluto's unusual orbit. After focusing on Pluto's situation, the fact that it could collide with Neptune one day concerns him. He states that this could lead to tremendous issues for our entire planetary system. A collision between Pluto and Neptune would be an intriguing yet serious event. It would release a vast amount of energy and could shatter Pluto. Fragments from the crash could zoom around space and potentially strike other planets and moons. Neptune could also feel the impact and change its movement. Famous theoretical physicist Michio Kaku, known for his contributions to string theory and science communication, offers a captivating perspective on space exploration. He firmly believes that understanding the fate of space travel and the relationship between celestial mechanics and theoretical physics can be gleaned from studying characteristics like Pluto's orbit. Kaku considers Pluto's orbit to be vital for grasping how larger planets influence its path. Kaku often likens Pluto's journey to a cosmic dance, emphasizing the importance of recognizing that its path is a result of interactions with other planets. He believes that the gravitational interactions between Pluto, Neptune, and other celestial bodies reflect fundamental principles of physics that govern the universe. This dance between planets sheds light on gravitational forces and their critical role in maintaining the stability of our solar system. In conclusion, Pluto's orbit is a reminder of the complex and interconnected nature of our universe. It serves as a testament to the ever-evolving understanding of celestial mechanics and the fascinating dynamics that govern the movements of celestial bodies. As we delve deeper into the intricacies of space, Pluto's journey stands as a captivating narrative of the beauty and complexity that surrounds us.